Hey guys, welcome back to the next video. In this video, we are going to talk about Kubernetes cluster introduction. Now, remember, in this cluster introduction, I think that you would have watched the previous video, which talks about the element of Kubernetes, or some of the features which of Kubernetes which you used in real world situation. And you know that when you talk about containerizations or orchestration of containerization, which is very much required nowadays with containerization. We first think about Kubernetes because Kubernetes is controlling currently 25% of the containerization market in terms of orchestration, and that is a huge percentage. Now, which means that a lot of companies are actually using Kubernetes as a solution for having the orchestration done for your containers. Now, there is also another software which is built on top of Kubernetes called OpenShift. Now, OpenShift uses the power of Kubernetes because it is both done by Red Hat. So it uses the power of Kubernetes and then designs certain things, above this level of Kubernetes clusters. And then it basically provides an enterprise grade service for managing or orchestrating the containers. Now let's talk more about Kubernetes. The first thing which you need to configure Kubernetes is hardware. Now the hardware could be a virtual physical hardware. It could be on a private cloud or public cloud. It doesn't matter. You just need a server which has an operating system installed in it and a good amount of CPU and RAM. Now, why it needs a good amount? Because we're going to run pods, which is going to be like a mini operating systems on your system. Now, in my training or tutorial, I'll be using my laptop itself rather than paying money for a public or private cloud. I'm going to utilize the power of my computer, my laptop, and then I'm going to do something over it. So I'm just going to have Kubernetes and all these other things which is already installed. So if you have seen my previous videos, you would have seen that we have completed the installation of Docker, Podman, and other cryo. That those installations are completed. Now those are operational. Now the next step towards that is to configure those containers. But before we go there, I just wanted to tell you about Kubernetes and have it installed as well. So now that you see that this is basically the platform which we're going to have, which is my laptop in this case. And then on top of that, I already have a Windows operating system, which is working currently. And that's what you're looking at it right now. On top of my Windows operating system, I'm going to have a virtual machine created for CentOS and then going to install, I've already done that, installation of Docker and blah, blah, blah. Now, what I'm going to do is I'm going to put this Kubernetes cluster on top of Docker and have that controlled from there. So not necessarily Docker is what I'm going to use. I'll be using Podman as well, but it doesn't matter what container I'm using until it has a CRI facility. So right now I have cryo as well, so which means that I can use cryo to manage those pods. I don't really need anything else. Or I can use Docker if I'm using in case of a Docker. Now, the next thing, what we're going to do is we are going to talk about the zoomed out layer of it. So as you can see that there is this 3 boxes over here, which is involved in this configuration. Now, when we spoke about the previous architecture of Docker architecture, now you would see very much straightforward. You have the Docker architecture, you have the OCI, which is the runtime interface. And then you have the containers. So it was so straightforward, so simple. You issue a command and then it just goes to the OCI and then it goes run C and then it executes the stuff by talking with the kernel parameters of namespace and C grouping. And then it creates the containers. But then here it's a little bit complex, I would say. Why? Because there is this 3 boxes. Now, whatever we discussed earlier is also here part of this diagram, but then it is on the large grand scheme of things. To start with, we are going to understand that there are three boxes over here with different colors. The first box over here is your blue box, and then the one is light green box. Now these boxes, the blue one is called the master node, and the light green one is called the worker nodes. So this is all about the communication between marker and worker nodes. Now, who is connected to the end user to provide information to the end user or to give an experience to end user? It is the worker node. The worker node is the one which is actually doing all this work is for the worker node. The arrow mark should be this way. I'm sorry, apologies for that. The arrow mark shouldn't be pointing this way. It should be pointing both the ways. I don't know why there is an arrow mark even there. So that shouldn't be there because there's already green lines going up and down, which indicates the communication coming to and flow. Well, anyways, forgive me for that the arrow mark shouldn't exist. So over here you have the master node, and then you have the worker node. So we call the master node as control plane, and we call the worker node as data plane. So what is control plane? Control plane is basically how you're going to control your entire orchestration towards getting things done and getting work done from your worker nodes. Okay, so first let's see the master node first. Let's just try to understand what's the master node. The master node is a control plane, as I told you, of Kubernetes cluster. Very simple. It hosts several components that includes API server, etcd, control manager, scheduler. So these are the things which is hosted on a control plane under a master node. So we will also see at what these each component does or how they contribute to control your control or orchestrate your complete worker nodes. We will talk about that in some time. But before that, let's understand the worker node here. Now, worker node are the compute nodes in the cluster where container runs. So this is where the user experience happens or user interaction happens. Each worker node container runs software like Docker or Containerd to manage this containers, or you can simply call it as CRIs. Now, a CRI should be here present to ensure that the control happens on all these containers or pods. Pods, which are smaller deployable units of Kubernetes that runs on the worker node. So pods, aka containers. So these are the containers which actually runs on the Kubernetes. In terms of Kubernetes technology, they call it pods. Now let's talk about each of the services which we have over here. Now, as I told you over here, the first service which it's going to connect to is the API server. Now, API server has a lot of APIs. So basically, it is the birthplace of all the APIs which is available here. So each API is going to spin up some kind of activity and it's going to connect it to something else. And then that's going to create another connection. So previously in any monolithic application, so you will see a big process and there will be a lot of process connecting to different processes. So what difference is this going to do is, like, rather than connecting to a big process, it has divided everything into a smaller pieces of work so that it can become faster and more effective in terms of delivering those content. And that's something you can see it here itself. As you can see that how many components are divided between inside the master node to do multiple different communications. You can understand those things right now itself while working on these concepts rather than just going into the deeper stuff. So let's just try to understand what is API server is. The API server is the front end of Kubernetes control plane. It exposes Kubernetes API with clients like kubectl, which is basically your command which you are executing as a user, your application, etc., used to interact with the cluster. Okay, so the next one we are going to talk about is etcd. So we will talk about this when when I'm explaining you about the flow of the Docker infrastructure, which will be on the next video. The etcd is a distributed key value store that stores all cluster data, including configuration, setting, and the state of the entire cluster, which is very important to know what is the current state of the cluster. Next point is that it ensures that the data consistency and fault tolerance is enabled. As it collects the data state, it will also have these information towards the consistency of data and fault tolerance. All right. We'll talk more in detail about the other aspects. Let's talk about controller manager first. The controller manager manages various controllers that regulate the state of the system. There are multiple controllers here, as I've given you some description about it. We will check that on the next video. Do not worry about it. The controller includes node controller, ensuring the nodes are healthy, replication controller, ensuring the desired pods replica are maintained, and more. So these are basically the bread and butter of your control plane or your orchestration. So those are the items which is going to be part of the control manager. This is just a small introduction. Next is a scheduler. Now you have this kubelet scheduler on the left hand end. The scheduler is responsible for placing pods onto suitable worker nodes based on the resource requirements, affinities or anti-affinity rules, and other policies. So scheduler takes care of the policies and setting up those policies where and when it's required. It also takes care of resource allocation or understanding the resource, or based on the resource, it will create pods in a proper worker nodes where the resources are plentiful. The next one we're going to talk about is something on the worker node. Now you know that how the control plane is going to influence the worker node, and which control plane would influence what items on the worker node. Now we need someone from the worker node to implement all those changes, correct? So we need an agent in place of a master node, where the master node's intention needs to be executed for that particular worker node, right? So those agents are nothing but your kubelets. Now, your kubelet is an agent running on each worker node. It communicates with the API server to ensure the containers in that pod are running in a healthy state, and also it acts according to the will of the master node or the API server. Now we have something called a kube proxy over here, which is kube proxy. It maintains network rules on the worker node. It enables network communication to and from the pod. So what actually it does is, like, it basically enables the communication, one, between pods, two, between worker nodes, three, between an end user and the pod, and four, between the administrator and the pod, using the master and worker node connectivity. So all these communication has been taken care by kube proxy. Next is the container runtime. So this is the CRI. So the very important thing over here is the CRI. Now, why it's so important is because who executes all those information? Now, the instructions are coming through from the administrator and then finally reaches the kubelet. Now, who will be actually executing these commands is your container runtime interface. CRI is going to be in charge who will be connecting to each of these pods and updating it accordingly. For example, a pod has failed over here. Now, this current state will be updated on etc, and then the control manager will run some kind of a replicant over here, and then the kube scheduler will understand the current infrastructure, which is what resources are acquired and what resources are free, and then basically ask the kubelet to create a particular node on that particular CRI under that particular worker node. Now, this is what is the architecture I wanted to explain. In the next video, we will be looking at something like the flow of the configuration. Now, you must have already understood the flow of the configuration, but then we will look at it one more time just to be more clear, and I will also give you much detail about the flow of configuration going forward. So, if you want me to explain this in a real world example, I can do that also. Let's just take another 5 to 10 minutes and try to understand this in a real world example. Let's consider a cloud native e-commerce application as a real world example in this case. This application comprises of multiple microservices, including product catalog service, a user authentication service, a payment gateway or payment processing service. Okay, so only 3 services: a catalog, authentication, and payments. Okay, so a pod and a container in this scenario, each microservice is packaged into a container and deployed into a pod. So instead of this 3, imagine that this is container, this is authentication and payment. For example, the product catalog service is containerized application running in a pod along with its required dependencies. Now let's talk about replica set and deployment, so which is the control manager point. Kubernetes uses replica set and deployments to ensure that the specific number of pods replicas are running at all times. So let's just consider that this worker is basically a replica worker, which is running all the time. So that way, if the actual pod fails, then it will automatically transfer that to the replica pod. For the product catalog service, a deployment ensures that a specific number of prod replicas are available to handle incoming traffic. That's basically what a controller manager does in terms of replication and deployment. I'm just giving you the example for the first 2 things. Rest of the things, there is also a lot of activity goes around that we are not discussing right now. The next service which we are going to look at is load balancing and Kubernetes service. Kubernetes service provides a stable network endpoint to access pods. For e-commerce application, a service exposure, the product catalog service of external user. So you can also configure a load balancer, which can be used to distribute the traffic across multiple instances of a service. So that is also possible in terms of Kubernetes. In terms of scaling, e-commerce application experience increased traffic, and Kubernetes auto scaling ability, which is also part of your controller manager, can automatically add more pods replicas to handle the load. So that can also be something which can be configured in your control plane. In terms of high availability, Kubernetes ensures that high availability by scheduling pods across multiple worker nodes. In case of a worker node failure, the controller manager detects it and it schedules a replacement on the healthy node by using the kube scheduler. In terms of updates and rollbacks, whenever a new version of microservice is available, Kubernetes can perform rolling updates, ensuring zero downtime on deployments. If an update has an issue, Kubernetes allows for easy rollback to the previous version. So that is also which can be used with the control plane. So I've just explained to you, when you're using an e-commerce application, it's going to be much simpler for you to manage when you had to do all these options earlier, when you're using a Docker container or any container for that matter, manually. Now you don't have to do so because you have a orchestrator working to ensure that you can automate most of the stuff which you do manually. Thanks again for watching this video. I hope it was helpful for you to understand a little bit about Kubernetes and its services it offers. And if you have any questions, please reach out to me on question sections. I'll be happy to help you out on that. And remember, your rating means everything to me. So a good rating would be very useful for me, as well as it be encouraging me to create more videos like these with an interactive diagram, which can explain things to you much easier and more effectively. Thank you again for watching this video. I'll see you on the next one.